All right, this is lesson 2.7, graph and write linear functions. Our con skills for Math 1 were from Unit 4 in Khan Academy, forms of linear equations, and this is going to match with skill number 6. Our objective is short today. It's that you'll be able to graph and write linear functions. We have the same table from our last lesson in 2.6. So remember that the y value is the right side of the table, x value is the left side of the table. Our y-intercept in linear function word problems have to do with the start, the initial value, things like that. And our x-intercept would be where it ends or finishes. Our slope is usually mentioned in the word problem when they're talking about a rate or a rate of change. They might say per, speed, or each. Let's go ahead and tackle example number 1. So I already read through it and underlined the important information like we do in our word problem strategy, but I'll read through it one more time. A pool has some initial amount of water in it. So that initial amount of water, remember our initial stuff, that's our y-intercept. This is you can think of it as the b value if you're writing it in slope-intercept form, or you can think of it as a point, 0, something. That something is the b value. That is our y-intercept. And then the pool starts being filled so that the water level rises at a rate of 5 centimeters per minute. It's a rate, so this is the slope. And it's telling us the slope is 5. It's going up 5 centimeters per minute. And then after 20 minutes, the water level is 220 centimeters. They're giving us a point here. When x is 20, y is 220. So that's going to be a point on our line. And then we're asked to graph the relationship between the pool's water level in centimeters and the time in minutes. And I apologize in advance. I don't know why this grid was chosen to be printed in your textbook. So bear with me. Just do your best. It doesn't have to be exact. When you're in Khan Academy, the graphs will look much nicer. But to start, before I uncover anything, I do want to point out that you should always, if you're creating your own graph, you should always do 3 things. First, draw your axes, your x-axis and your y-axis. Next, you need to label your x-axis and your y-axis. And the label is right here. So we're saying that the variable x, represents time, and that's measured in seconds. And the variable y represents the water level measured in centimeters. Once you have your labels, then the last thing you need for a good graph is a scale. So I have these little tick marks here. Here, let me just get rid of that. I have these little tick marks. And when you make your graph, try to have 8 there so that you can count by tens and get all the way up to 80. And then on your y-axis, go ahead and make, we'll go with 5 tick marks, and you can count by hundreds. I'll give you a moment to get your graph made. You don't have to have the line yet, just have your x and y-axis. We'll talk about the line in a moment. Okay, so pulling from our word problem, we already saw that the slope is 5. We were also given a point on our line. Now remember, you need 2 points to determine a unique line. So we have 1 point, and if we use our slope, we can draw a slope triangle to find another point, and then draw our line. For this problem, I chose to use point-slope form, since we're given the point and the slope. I plug those values in. You can see the 220 and the 20 in green, and the slope right there in blue. I went ahead and distributed to isolate y and get this in slope-intercept form. So we know that we could put a y-intercept at 120 and a slope of 5. So one thing to note about the slope is if the slope is 5, that's 5 over 1. And we can multiply the top and the bottom by the same number, any number we want. And if we're doing it to the top and bottom, like maybe I could do 2 over 2. I'm not changing the value of 5. I'm just saying that the slope could be thought of as a rise of 10 and a run of 2. Or you could multiply it by something else. You could multiply it by, I don't know, 20 over 20. And then you'd get 100 over 20. The trouble here is that our point that we were given isn't really going to be a lattice point, at least on your paper. On mine it is, because I have a very fine grid. Yours should have looked like that. It just didn't print that way, so I apologize. But hopefully you can take a look at my graph and agree that this green point is in fact the point 20, 220. If we trace this line, oof, that's so big. But trace that line down, the x-coordinate is 20. Trace this line across, and the y-coordinate is 220. From there, you can draw your slope. I'm going to zoom in a little bit. Again, this will be much nicer on Khan Academy, so just bear with me for now. But on my screen, I know it's not on your paper. 5, 6, 7, 8, 9, 10. It takes 10 of these little grids to get up to 100. So each tick mark here would be 10. I'm not going to write all that. But if I draw my slope triangle and I were to go up 1 and over 2, I'd really be going up 10 and over 2 boxes. Well, that would be over just 2. Because to get from 20 to 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be scaled by 1s. So our slope ends up being 10 over 2, which is what we wrote here. That's how I got my next point, and then I drew my line. Okay. I was going to have you do problem 2 on your own, but again, because the grid lines printed so poorly, let's just go through this one together. So take a moment, draw your x-axis and your y-axis. Make sure you label it. Our x-axis should be time measured in minutes, and our y-axis should be temperature measured in degrees Celsius. And then we need to scale it. So here, let me just get rid of this covered part anyways. Okay, so we know Joe returned home one hot summer's day. To find it sweat-inducing hot, he turned on the air conditioner and fell asleep. So the room's temperature is decreasing at a rate of 0.5 or 1/2 of a degree Celsius each minute. And Joe woke up 60 minutes later when it was 10 degrees Celsius. So I underlined some important information. I color-coded it for you. So our slope, because it's saying that it's decreasing, that's a negative 0.5. And then they give us a point where the x-coordinate is 60, the y-coordinate is 10. So that's the point there. We can plug those values into point-slope form and solve for y to get slope-intercept form. And then we could graph it. We could find the y-intercept of 40, and then the slope is negative 0.5, which is saying that the slope is negative 1/2. In other words, the rise is going down 1 before we run 2. Now keep in mind, negative 1/2 is equivalent to negative 10/20. So I could, after after plotting my y-intercept, I could go down 10. So I go down from 40 to 30. As long as I run 20. So I go to the right 20. See how this is actually 20. And I find my next point. And then you have 2 points. You can graph your line. Notice that if you were to continue the pattern out, draw another slope triangle and keep going, you would eventually hit that point that we were given with to start with. That's the point 60, 10. So that's a good sign. You could have also chosen to graph using intercepts. You could pick out the y-intercept pretty quickly. And then if you chose to plug in 0 for y and solve for x, you would have found that the y-intercept is 80. And then you could use those 2 pink dots to draw your line as well. Again, thank you for bearing with me. The graphs will look much nicer on Khan Academy. All right, so that's graphing linear functions. You might also need to just write a linear function. So here's some examples and practice problems of that. Let's go ahead and read our problem. Yak Travel Agency arranges trips for climbing Mount Everest. For each trip, they charge an initial fee in addition to 15 cents for each vertical meter climbed. For instance, the price for climbing all the way to the summit, which is 3,500 meters above the base of the mountain, is $645. Okay, so I underlined the important information. One thing you should know is that this 15 cents, it's 15 cents for each vertical meter climb. That's a rate, so that's our slope. And then they give us, underlined in red here, an ordered pair. In other words, when x, the distance climbed, is 3,500, the cost of that climb is $645. I might have gotten a little bit ahead of myself here because it also says let f parentheses d. That might be new to you. This may be the first time you've seen this. This is read, let me zoom in. This is read f of d. It's not talking about multiplication here. F is actually the dependent variable. So think of, in our last video, the dependent variable was y. Instead of y, we're just writing this in what's called function notation. So f of d is, you can think of it as y. And they put of d just to signify that f depends on d. So this d, this independent variable, that takes the place of x in our last video. Okay? So I still used y's and x's here for our point slope equation. Our information that we got from the word problem, we can plug that in. We plug in our slope, plug in our x and y coordinates, and then we can take this point slope form and convert it to standard or slope intercept form. Distribute, add 650 to both sides, and now we can see that this line has a slope. Well, we already knew it had a slope of 0.15, but it has a y-intercept of 120. All we're going to do here is replace y with this new notation that we're using, the dependent variable, and replace x with this new notation. We're going to use d for distance climbed. And that's it. That's our functions formula. It's in slope-intercept form. This is the same as y equals mx plus b form. I do want you to try this one on your own. It's very similar to example 2. So take a moment, pause the video, and come back when you're finished with practice problem number 2. All right. So we have a word problem about Norma, who drove from the Dead Sea up to Amman. Her altitude was increasing at a constant rate. That's our slope. This blue part here is a given point. That's also our y-intercept because x is 0. So you could have thought of that as b equals 400. And then we were also given this green part here. It's another point, 2 comma 1,000. In 2 hours, her altitude was 1,000 meters above sea level. Again, this is a of t. It's not talking about multiplication. It's just saying that the dependent variable a depends on the independent variable t. But the process is the same. You can find your slope. I chose to find it using the slope formula. I subtracted my y's, subtracted my x's, divided and got 300 for my slope. I put that in here, and I knew already that my y-intercept was 400. So I put my equation in slope-intercept form, and instead of x and y, I used t and a of t. All right, example 3. We've got Zane again in a volcano, and likes to go rock climbing in active volcanoes. One time while inside a volcano, he heard some rumbling, so he decided to climb up out of there as quickly as he could. He climbed up at a rate of 4 meters per second. That rate is our slope. After 3 seconds, he was 13 meters below the edge of the volcano. Remember the last video I drew a picture? I didn't draw one this time. He's going to be at a negative height until he gets to the edge of the volcano. So because it said after 3 seconds he was 13 meters below, that's why I have a negative 13 here. A common mistake is people will just put 13, and that doesn't model the situation correctly. We have 2 questions. I circled them both. How far was Zane below the edge of the volcano when he started climbing? So that's, because it's saying when he started climbing, that's our initial value. That's our y-intercept, or our b value in y equals x plus b form, or y equals mx plus b form. Our second question that I circled in purple is actually asking for the x-intercept. How long did it take Zane to reach the edge of the volcano? That's the end. Once he gets to the edge of the volcano, he's safe. So it's going to take a certain amount of time to get to a height of 0, because before he's underneath that height, he'd be negative. All right. So next, I used point slope form to plug in my point and my slope. And then I distributed the 4, subtracted 13 from both sides to get our equation in slope-intercept form. From there, we can answer our questions. We can tell from slope-intercept form that the b value is negative 25. We need to answer with units, make it make sense, explain it. So he was 25 meters below the edge of the volcano. And if we want to find the x-intercept, that means we need to plug in 0 for y. So there's a 0 here instead of this y. And we should get x equals 6.25 seconds. Our last problem I want you to try on your own about Miss Belial and her obsession with Kate Spade purses. Okay, go ahead and check your work. I underline the important information. This time it's asking us for the slope. We're given the y-intercept, and we're given another point. So there's a couple ways you could do this. You could just use slope-intercept form and realize that that m value is unknown. So you plug in your point and your y-intercept, solve for m, and then you can put that value of 2, the slope is 2, put that back in for m to get slope-intercept form. Or if you'd rather just use the slope formula, because technically you do have 2 points, you could just use the slope formula, find that it's 2, and then put it back in here to get your y equals mx plus b form. From there, the first question is answered because it's asking for a slope. How many purses did she buy at each store? It's 2 purses per store. The second question is asking you to evaluate that function. Plug in 11 for x, the number of stores that she visits. And then if you plug that in, you should find that she'll have 26 purses after 11 stores. That's it for chapter 2.7. Don't forget to type a question at the end of this video, and I will see you in class.